So we've been looking at contribution of food to global warming in the last couple of podcasts, our carbon footprint. There is another way to look at it, and that is to say if we set a global warming target of 2 degrees centigrade above the pre-industrial level by 2100 with a 66% probability, or 1.5 degrees C above the pre-industrial level, then how can we adjust the food contributions to meet these global warming targets? Every year there is a report put out by this group, the UN and DTU partnership, which looks at the so-called emissions gap. What is that? Essentially, it looks at how much carbon we can emit to hit these targets of 2 degrees C or 1.5 degrees C, and where we are headed as of now, and how much the emissions have to be reduced to stay within those targets. Or how could we do it? The warming, very quickly, is related to the carbon that's been accumulating in the atmosphere, and the warming rates are essentially linearly related to the accumulated carbon. This allows us to see when we will hit the warming targets based on the emissions trajectory we are on. So there are lots of uncertainties, of course, in terms of where the carbon goes and whether this relationship holds as we go forward and so on. But let's leave aside the details and just look at a few things again. This is the global greenhouse gas emissions from all sources for 1970 to 2020. So this is now including the land use, land change, forcing, and methane and N2O and the flue gases as well. Typically we have looked at many figures where those were not included. We were just looking at fossil fuels and so on. So nothing much changes. Global greenhouse gas emissions in gigaton CO2 equivalent from 1970 to 2020, where 2020 numbers for land use change and fossil fuel were not available yet, so you can see the gap there. And the story is the same, that almost all the emissions are coming from fossil fuel burning. There is a little dip here that corresponds to the COVID lockdowns, and there is a contribution from land use, land change, forcing. And you have the contributions from methane and N2O without saying what the sources are. How do we look at the emissions gaps? We start in 2015 and again look at gigaton CO2 equivalent. So now we have converted methane, N2O and flue gases into CO2 using the global warming potential calculations. Turquoise area shows the pathways limiting the global temperature increase to below 2 degrees centigrade. So we are here 2 degrees C warming target, and green area shows pathways limiting global warming increase to below 1.5 degrees centigrade with a 65% chance by 2100 minus 3% chance of the course of the century, over the course of the century. Okay, so there is a range of plus minus 3 degrees allowed here. So if we stayed on the policies that were there in place in 2010, by 2030, so this time horizon here is 2030, we would reach the warming here, which is clearly way above 2 degrees C target. So this is in terms of the gigaton CO2 equivalent. That's the emissions trajectory we would be on if we stuck just to the 2010 policy scenarios. Current policy scenarios have brought that number down by a bit. So from reaching 60 to 63 gigaton CO2 equivalent by 2030, we will reach maybe 54, 55, or about 53 gigaton CO2 equivalent. Then you look for various other requirements that are there. So every country has submitted something called the nationally determined contributions under the Paris Agreement, and those NDCs, nationally determined contributions, can be split into unconditional and pledge scenarios and conditional NDC and pledge scenario. What does that mean? Developing countries will do some things even if they don't get any financial help. I hope I didn't move the camera out of the range here. Even if we yeah, let me adjust this. Sorry. Even if they don't get any help on carrying out their pledges and NDCs, they will do something. Those are called unconditional NDCs and pledge scenarios, whereas there are additional reductions possible if there is something like a green fund made available to these countries. Then they will do additional things under their NDCs and pledge scenarios, which would bring down these emissions further. So if we take here the remaining gap to stay within 2 degrees C by 2030, then unconditional NDCs would require further reduction of 13 gigaton CO2 equivalent by 2030 to stay on target. Conditional NDC and pledge scenarios would require further reduction of 11 gigaton CO2 equivalent by 2030. But if you want to aim for 1.5 degrees C change by 2100, this we're talking about a warming target that we have to meet at 2100, but the emission scenario we have to hit already have to reach these number by 2030. So we would need 25 gigaton CO2 equivalent further reduction from conditional NDC and pledge scenarios, and 28 gigaton CO2 equivalent. These are median estimate of level consistent with 1.5 degrees C. So that's 25 gigaton CO2 equivalent range with a range of 17 to 33 gigaton CO2 equivalent. The median estimate of level consistent with 2 degrees C is 39 gigaton CO2 equivalent, ranging over 33 to 49. Okay, so I hope you get the idea. We can look further here from 2030 onwards, and that is this figure. So we left off here in the above figure. So this is from 2030 onwards to 2050. Again, the 2010 policy scenario, the current policy scenarios, they would give us a warming of 2.8 degrees centigrade with a 66% chance. Unconditional NDCs and pledges would bring us down to 2.7 degrees centigrade with a 66% chance. So that is not much of an improvement at all. Unconditional NDCs and pledge scenarios with net zero targets that every country is now announcing as COP26 is underway. I think China announced 2060 a while ago. India announced year 2070 as the target to reach net zero. So that would bring us to 2.2 centigrade at 66% chance, without worrying about how we would get there. And then you have a bunch of other scenarios for 2 degrees C, 1.8 degrees C, and 1.5 degrees C, and where the gigaton CO2 equivalent has to go to meet these targets by 2050. Okay. One sad example of how humanity forgets the priorities is the COVID came along. There was a massive crash in economies, losses in businesses, productivity losses, and lots of deaths, of course. But a lot of recovery funding was done. How did the recovery spending go as of May 2021 across sectors by region? So low carbon initiatives are shown here and high carbon measures are shown here. We are looking at different regions: Africa, Asia, Europe, Latin America, North America, and Oceania. And under low carbon scenarios, we are looking at clean energy, clean R&D, clean transport, energy efficiency, natural infrastructure, and armed. Okay, those are in the low carbon measures. And you can see that Asia did some good investment in clean energy, so did Europe, but not so much from North America. Clean R&D, research and development, Europe did well. Clean transport, Europe did well. But look at the percentages of the total funding there, okay? Energy efficiency. So Europe in general has done well, but it is more than compensated here when you look at high carbon measures. European investment of the recovery spending into traditional transport was quite massive. It was over $150 billion, and then some investment by Asia and Latin America and US as well. Traditional energy, Asia put a lot of money into a lot of the recovery spending into traditional energy. So this is an example of how the climate action can be a two-step forward, one-step back kind of a dance. If there is an economic crash, if there is any kind of disaster like the pandemic which causes an economic crash, then the efforts to boost the economies make some noise about climate action, low carbon measures and so on, but quietly there is much more investment done into what works quickly, and those are the traditional high carbon measures. For example, just today it is reported in Washington Post that Biden is talking a lot about climate spending, clean energy, but he's also asking for more production of oil. Okay, that's fossil fuel. So these are the issues we have to deal with. So coming to food emissions could consume most of our 1.5 degrees C or 2 degrees C carbon budget. Shown are estimates of cumulative greenhouse gas emissions from food production from 2020 to 2100 based on population, dietary and agricultural trends in a business as usual scenario, which means we don't change any policies. This is shown relative to total cumulative emissions to keep global average temperature rise below 1.5 or 2 degrees C by 2100 with a 66% probability. Food emissions under business as usual, 1356 billion tons of CO2. To have 67% chance of staying below 2 degrees C, we could emit only 49 billion tons of CO2 from all non-food sectors, which means if food sector took up so much, the non-food sector would have a room of only 49 billion tons of CO2 for staying within the target. For 1.5 degrees C budget with a 67% chance, from 2020 onwards, 500 gigatons, we can only emit another 500 billion tons of CO2 equivalent to have a 67% chance of staying below 1.5 degrees C. Even if we stop all emissions from non-food sectors, for example energy and industry, today food emissions alone would take us well beyond 1.5 degrees C by 2100. And if you reduce this chance to 50%, we would get a bit more room for emitting more carbon. Again, food will take up almost all of it. 2 degrees C budget with 67%. 1405 gigatons is what we would be allowed to emit total. And again, food could take a lot of it. 2 degrees C budget with 50% chance would give us room for 1856 gigatons CO2 equivalent by 2100. So these are the various limits we are looking at. So what are the opportunities? How can we reduce global greenhouse gas emissions from food? Shown are the estimates of cumulative greenhouse gas emissions from food production from 2020 to 2100 under a business as usual scenario, and 5 interventions to reduce these emissions. Of course, we are doing the global warming potential kind of conversion to CO2 equivalent. Business as usual, as we said, has this much room for food. Food emissions from 2020 to 2100 if we achieve one of the following. Okay, so if we have high yield crops, we could reduce this number by 14%. If we halve the food waste that we have going on now, we could reduce the emissions by 27% by 2100. Healthy calories. Remember, we looked at meat consumption, milk, dairy products, vegan, vegetarian, pescatarian, and so on. Healthy calories would give us a 30% reduction from business as usual by 2100. Best farm practices in the lower emissions intensity would give us 40% reduction. plant-rich diet, so going away from meat, so reduce the meat. It's not vegan, so you could still have dairy products, for example, could give us 48% reduction from business as usual from 2100 levels. Food emissions from 2020 to 2100, if we achieve all of the above together, we could get a total of 63% reduction, partially or fully. So partially is 63%, and if we fully implement all these together, we could get 101% reduction. So we could even go minus 7 gigatons. So we could save emissions from food sector. So if we adopted all 5 interventions, we could reduce emissions but also sequester carbon by growing forests and grasslands on current farmland. This would result in net negative emissions. So here are the 1.5 degrees C with 67%, 1.5 degrees C with 50%, 2 degrees C with 67%, and somewhere here should be 2.2 degrees with 50%. Okay, so this is a good way of thinking about food as a contributor to the solution, instead of just looking at how much carbon each thing emits and how we can reduce our carbon footprint. Here we are directly trying to estimate the room we have in terms of carbon emissions out to 2100, and in terms of carbon budget, and then how we can reduce the carbon footprint of the food sector. Okay, so this gives you another way of thinking about how you would contribute, how you would teach your children and grandchildren to contribute for their own future. Okay, let's leave it here.